Assalamu alaikum. Welcome to eSafe Science. Today we are going to discuss about electronics. Electronic is the easiest lesson in grade 11. Electronic means controlling the movement of electrons according to our requirements. So, first of all, we want to understand what is electricity. Electricity means movement of electrons in a particular direction. Materials that conduct electricity are known as conductors. Now we are going to investigate what are the secrets behind a conductor to conduct electricity. Here I have expanded a portion of the conductor. Now you can see there are free electrons in the conductor. They are moving randomly. Now I am going to on the switch. Now the electrons are moving from the negative terminal to positive terminal of the battery towards the conductor. So the electricity flows from the positive terminal to negative terminal in the circuit. So we can understand the direction of electricity is opposite to the direction of electron movement. Then the direction of current flow occurs the opposite to the movement of electrons. What happened to the conductivity of the conductor when the temperature increases? Now we can see the temperature increases, the atoms in the conductor vibrate. So the vibrating atom disturb the flow of electrons. So the current flow decreases. So we can conclude when the temperature increases, the conductivity of metal conductor decreases. Now let's see semiconductors. Semiconductors are in two types. The first one, intrinsic semiconductors, extrinsic semiconductors. Now study about the intrinsic semiconductors. These intrinsic semiconductors are pure semiconductor materials such as silicon and germanium. These elements belongs to group 4 in the periodic table. Now let's see how these intrinsic semiconductors are in the lattice form. I take silicon as the first example. As silicon belongs to group 4, there are 4 electrons in the outermost cell of silicon. This is how silicon atoms are arranged in a silicon lattice. Now here we can see these electrons, outermost cell electrons are making bonds, a covalent bond. Now we can see every silicon atoms making covalent bonds with other 4 atoms around it. Here 2, 4, 6, 8. So the silicon atom gets the stable electronic configuration. Now we can't see any free electrons here. So no possibility to flow an electric current. In 0K. So, in the absolute temperature, this lattice does not conduct electricity. But when the temperature increases, what will happen? Let's see. These bonds are weak. When the temperature increases, what will happen? Now you can see here the bond is breaking. A free electron releases. And what happened to the space? There is a hole. This hole represents the positive charge. When a bond breaks, a free electron and a hole form. So, around this lattice, the number of holes and the number of free electrons are equal. So, we can say this intrinsic semiconductor is electrically neutral. We know this positive charge carrier attracts the negative charge carrier. So, this hole attracts other electron. So, electrons jump to these holes. Like this, electrons can jump to the adjacent hole. So, there is a electron flow can occur. So, there is possibility to conduct electricity. Now, let's see what happens when an external potential difference connected to this intrinsic semiconductor. Now, I have connected the positive terminal to this side and the negative terminal to this side. Now you can see what's happening. At the end of this negative terminal, electron releases, hole forms, and the free electron runs towards the hole. Then another free electron runs towards the hole at the positive terminal. Then the hole at the positive terminal disappears. And this free electron runs towards the positive terminal. So, we can say the holes are moving from the positive to negative and electrons are moving from the negative to positive. Okay. Next to that, let's see what are these extrinsic semiconductors. Extrinsic semiconductors are formed by doping the intrinsic semiconductors with group 5. We know these intrinsic semiconductors are pure lattice. All atoms are same. Now, this group 4 lattice going to mix with group 5. We can use phosphorus, arsenic or antimony to mix with this silicon lattice to make a N-type. I will explain how an N-type is formed. Arsenic atom is going to mix with this silicon. So, we can take an arsenic atom here. Arsenic belongs to group 5. So, how many electrons are there in the outermost shell? Group 5, 5 electrons. Now, we can see 1, 2, 3, 4. 1 electron left without the bond. We know Once again, I will explain. This arsenic has 5 electrons. 1, 2, 3, 4, 5. Of these 5, 4 electrons are making bonds with silicon. 1, 2, 3, 4 are with bonds. Only 1 electron left without a bond. So, we know this pure lattice is electrically neutral. Now, a negative charge is excess here. So, this become the neutral become negative. Now, this is not an intrinsic because it is mixed with. The mixing process is called doping. After the doping, this become extrinsic. Cut this. Now it is extrinsic semiconductor, electrically negative. So this type is called N-type. N-type extrinsic semiconductor. We can see this arsenic atom gives one extra electron to this lattice. So, it is donating a negative charge. So, this atom is called donor atom. This is donor atom. Okay, next to that, let's see the p-type. Intrinsic semiconductor mix with group 3 element. We can use boron, aluminium, germanium or indium to mix with. Now we can see the example when mixing boron, what happened here. We know boron is group 3, so there are 3 electrons in the outermost cell. Now this boron makes covalent bond. 3 bonds, only 3 electrons. So 3 bonds, 1, 2, 3 bonds. So in this side there is a space. This space needs an electron. An electron needs space. Electron deficiency space. So we know what charge does this space represent? Positive. So, this lattice has a positive excess. So, it is always trying to accept an electron from anywhere. So, this boron is called acceptor atom. Acceptor atom. So, now we can say this lattice represent positive charge. So, this type can be explained p-type. Now we can conclude. There are 2 types of extrinsic semiconductors. We can conclude extrinsic semiconductors are in 2 types. N-type and p-type. This N-type can be formed mixing group 4 with group 5. As this group 5, we can mix phosphorus, arsenic, antimony. These group 5 atoms are called donor atoms. N-type can be formed mixing group 4 with group 5. As group 5 elements, we can use phosphorus, arsenic and antimony. These group 5 atoms are called donor atoms. We can form a p-type mixing group 4 with group 3. As group 3, we can use boron, aluminium, gallium and indium. These elements, group 3 atoms, are called acceptor atoms. Now we know N-type, P-type. Next to this, we are going to go to P-N-type.